Hello everyone. In this video we're going to be evaluating tangent pi over 8. And I'll be presenting three methods. Let's start with the first method. So for my first method, I'm going to use what is called the double angle formula for tangent. As you should know, tangent x plus y can be written as tangent x plus tangent y divided by 1 minus tangent x times tangent y. And if you replace y with x, you get a formula for tangent of 2x, which can be written as 2 times tangent x divided by 1 minus tangent squared x. So that's the double angle formula for tangent. That's what I'm going to use for my first method. Now how do I use it? Notice that pi over 8, if doubled, becomes pi over 4, and I do know the tangent of pi over 4. Hopefully you do too, right? What is tangent pi over 4? Well, pi over 4 radians corresponds to 45 degrees, and tangent 45, as you should know from this triangle, is 1. Okay, so tangent pi over 4 is 1. Now let's go ahead and replace x with pi over 8 in this formula and find tangent pi over 8 from there. So tangent 2 times pi over 8 is equal to, from this formula, 2 times tangent of pi over 8 divided by 1 minus tangent squared of pi over 8. I'm not putting the pi over 8 in parentheses, but if you're worried about it, I can. Some people are really picky about it. It's usually understood, but in case you're being very careful about these things, here we go. Okay, so this is tangent pi over 4, so this is equal to 1, as you know, right, from here. And now this gives us a really nice equation, and guess what? It is quadratic. Let's go ahead and call tangent pi over 8. What variable would be appropriate? Let's call it t, right? Obviously. And then from here we get something like this, 2t, or not 2t if you're a tutor, divided by 1 minus t squared is equal to 1. Notice that tangent pi over 4 is 1, so we set it equal to that. Now let's go ahead and cross multiply. 2t equals 1 minus t squared. Let's put everything on the left hand side. T squared plus 2t minus 1 equals 0. This almost looks like a perfect square, but it's not, because c is negative. Make sense? Okay, great. Now let's solve this. You can use a couple different methods. One of them is something that used to be called Paushan law method, and I made a video about it because he was, I believe, the first YouTuber to announce it, even though this method was known for so many years. Anyways, we're going to complete the square, and I think that method depends on Vieta's formulas, but anyways, I'm going to go ahead and first add 1 to both sides, and then I'm thinking, what should I add to both sides to complete the square? And the answer is as follows. You take the coefficient of t, or any variable, divide by 2, and you square that number. In other words, if you had t squared plus bt, you would be adding half of b squared. Make sense? Okay, great. But of course, we have an equation, so we have to add it on both sides. And this becomes 1, right? So I'm adding 1 to both sides, and a lot of times people know what to add real quick, because you've seen this probably many times if you've done some algebra. When you see t squared plus 2t, you add 1, okay? Now the left-hand side becomes t plus 1 squared, and now you can take the square roots, easy to solve, plus minus root 2, and then you just add -1 to both sides or subtract 1, and you get, Notability does that if you hold it for a while, and you get -1 plus minus root 2. Which value am I going to use? There are two values, but the answer should be unique, right? Now think about it. Tangent pi over 8. Pi over 8 is in the first quadrant. It's less than pi over 2, so it needs to be positive. So I'm going to go with -1 plus root 2, or you can write it as root 2 minus 1. All right, that's the first method. Let's go ahead and take a look at the second method. Now, the first method used double angle formula, which you should definitely memorize if you're doing trigonometry. Even if you're not doing trigonometry, just do it because it's fun, right? So the second method depends on geometry. And this is really a cool method. If you're trying to cut an angle in half, like let's say you're trying to find tangent 15, tangent 22.5, which is, by the way, pi over 8, right? This method is super helpful. So we're going to first start with our isosceles right triangle. Remember, we just talked about it, right? And this angle is pi over 8. And I'm just going to take 1, 1, root 2. Actually, it doesn't matter. You can also take x root 2, or whatever you want. It doesn't matter. But I'm going to try to keep it simple. Here's the critical part. Suppose I call this triangle BCA, ABC, whatever you want to call it. Anyway, anything is fine. But in this triangle, I'm going to take AC, the side length, not the air conditioning, right? And extend it as long as BC. So, and I'm going to call this point D. So CD is going to be congruent to BC, which means it's going to be root 2 units as well. You get the idea? Okay, that's the strategy. And now I'm going to connect B and D. And that's going to give us, and I'm going to do it with a zigzag line because notability can make a straight line. Yes, awesome. Now, why did I do this? First of all, let me explain this real quick. The reason why I did that is because by extending AC and make it the same length as BC, I got an isosceles right triangle, which is BCD. Do you see that? So the angles are going to be congruent and the base angles. But wait a minute, from exterior angle theorem, their sum is pi over 8. Wait a minute, did I put pi over 8? Are you serious? That's supposed to be pi over 4. Sorry, I'm ahead of myself. So, oops, I did it again. Just a habit. This is supposed to be pi over 4. And this is also pi over 4. Uh-oh, I didn't want to erase everything. So let me magnify this a little bit. And maybe I can even make my eraser a little smaller. Right? Yay. Awesome. So now we're going to go ahead and call this also pi over 4. Right? Because that's my original triangle. And now notice that these two angles are congruent and their sum is pi over 4 because that's the exterior angle. So each of these must be pi over 8. So that's the secret behind this geometric method. And it's really awesome because it's very visual. And from here, tangent pi over 8 just becomes opposite over adjacent, which is 1 over root 2 plus 1. And then at this point, you can go ahead and multiply by the conjugates. And you get the same result, root 2 minus 1, because this becomes 1. You get the idea? Awesome. It's really cool and very helpful method. Now let's go ahead and talk about the third method. I don't know if you really thought about a third method. If you do know of a fourth one, please share with us. But the third method that I'm about to share with you is going to use complex numbers. And guess what? Complex numbers are awesome, don't you think? And I have a channel dedicated to complex numbers, which is called aplusbi. Okay, a little bit of shameless self-promotion. Okay, great. Now, let's go ahead and see how we can use complex numbers to solve this problem. I'm going to consider the square root of 1 plus I. Why? You might be questioning, right? I know that. Because 1 plus I, the argument of 1 plus I is pi over 4. And by taking the square root of that complex number, I'm cutting the angle in half because the rule says by the more, I can never say that, but hopefully you get the idea. He's a French guy and he came up with the formula. So by taking the square root, you're basically cutting the angle in half and square rooting the modulus. Makes sense? So in other words, if you have r e to the I theta and square root that becomes the square root of r times e to the power I times theta over 2. Of course, this is one of the square roots. It's probably the principal one, but this is good enough. Okay? So I got the argument, but how do you write this in polar form, right? That's the million-dollar question. 1 plus I on the Argand plane, I'm pronouncing the D by the way, is actually given by this number, which is kind of 1, 1, imaginary and real, right? And this is basically root 2 units away from 0, which is its modulus, by the way. And the angle, theta, is just going to be pi over 4. We already talked about it, right? Exactly. And the modulus is root 2, which is r. So I can kind of write this as root 2 times what? E to the power I times pi over 4. Great. And then by taking the square root, I'm basically getting the square root of the square root of 2 times e to the power I times pi over 8. So this is going to give me, hopefully, tangent pi over 8, right? Okay, great. But what is the square root of 1 plus I? How do you find it? Okay, you can think of it this way. Square root of 1 plus I is, suppose we call it a plus bi. Square both sides. You're going to get a squared minus b squared plus 2abi. From here, you can set a squared minus b squared equal to 1 and 2ab equal to 1 as well. From here, ab becomes 1/2. And then if you replace, I don't know, b with 1 over 2a, or you can do the following. You can square both sides and then just replace a squared with b squared plus 1. And if you do that, you're going to get b squared times b squared plus 1 equals 1/4. This is b to the 4th plus b squared minus 1/4 is equal to 0. And you can kind of call this c, and you get c squared plus c minus 1/4 is equal to 0. And from here, c becomes negative b plus minus the square root of b squared, which is 1, minus 4ac, which is 1 again, and divide by 2. C becomes 1 minus plus minus, but notice that c is real because b is real, so it needs to be positive, and it just becomes root 2 minus 1 over 2. What is c? C is b squared, set it equal to b squared, so b is going to be the square root of root 2 minus 1 over 2. Wow, that's such a long method, right? Great. Now, you got the b value. From here, you can find the a value. By replacing a and b with those, you're going to find the square root of this number, which can be written as a plus bi, and then from there, hopefully, you can find the value of tangent pi over 8. By the way, b over a is just going to be tangent pi over 8 in this case. And I'm going to leave that as an exercise for you. And this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.